So I need you to go to formative.com. When you get there and you click on login, make sure you log in, so do the login with Google part, and use your district credentials. Then that way when you get in there, you didn't have to join that class because you joined my Google Classroom, and you're automatically in my formative class, and you should see today's notes, okay? And along with that, I can see what you're doing in formative and that you're actually taking notes. So go ahead and get in there, find it. Should be like the only thing you have, I would think. And navigate to the first page, and then I'll be able to tell when everybody's. So we're going to look at relation and function review. Okay, so it is a review, stuff we should have seen before. So let's talk about what relations are. Relations are just, oh goodness, it's like I'm new or something. They are just sets of ordered pairs. Okay, sets of ordered pairs. And don't worry, because you're writing on formative, I'm going to go a little slower for a while. Might also help if you turn your phone landscape, because then it would make it bigger. You can expand. It's up to you. It's up to you. You can do whatever works for you. But all right, so an example could be like -2, 3, 4, 0, 2, 7. There's a set of ordered pairs. That's a relation. If you have a stylus, they work pretty well on your phone too. Like if you have one that you were using on your tablet. Yes, that's part of it. If you don't write the squiggles, it's wrong. Yes, 100%. Everything I just wrote, if you don't have any part of that, then it's wrong. What you're saying doesn't make any sense. You got to write the bracket. That's what makes it a set inside of that. Okay. All right. So there are different ways to represent relations. We could do that with a table. We could do that with mapping. We could do that with a graph or equations. It's not a map, it's a mapping. Those are two different things. All right, so in the table, let's put some numbers here. We're going to put, in the x's, 2, 4, 2, 8, and then -2, 0, 7, 12. Hamid, where's your definition of a relation? Huh? It's up there? All right. Mapping, we're going to use these numbers in our first oval. We're going to have -9, 0, and 2, and then 5, 7, and 9. So when you have a mapping, we could say that -9 maps to 9, 0 maps to 7, 2 maps to 5, as an example. All right, on the graph, we can put a few points here. This could be an example. I at least want like these to be on top of each other, otherwise it's fine. And then an equation, we could have y equals 3x squared plus 7. Yeah, I know the graph is not ideal. It's kind of tiny. Again, you'll get better at this, I promise. It'll get easier for you. You won't get as frustrated. So when you're done with that, if you don't have any questions, there's a checkbox on the top right. It'll take you back to the page before, and then you click on Show Your Work for the next one. Emma, did you have summer school? Is that why you have that tablet? Because you had summer school? Yeah. Hey, but you know what? Now you have a touchscreen tablet, so just... Okay. All right. Are we good? No? Okay. How do we do? No, ask questions. How do we what? No. So go on to the next slide. So we can talk about domain and range. You've been talking about domain and range for like ever, right? You would be surprised at the crazy kinds of answers I get on domain and range from students such as yourself. So I don't think it's always just a matter of you completely don't understand what it is. I think a lot of times you don't completely understand how to express it correctly in writing, and that could be a huge problem. Okay? So let's look at that. So our domain is the set of all x values. Now, this isn't the best definition in the world because do we always have to call it x? No. So there's better ways to say it, but I know you know what that means, so it's good enough and it's short enough. And then range would be the set of all y values. You are way too far along in your math careers to mess those up. There's no reason you don't know which one is domain and which one is range anymore. You don't have time or room for those kind of mistakes. Now, of those, because we could call them other variables, one of them is independent, one of them is dependent. Which one is dependent? Y, the range. Very good. So this is the dependent. This is the independent. All right, sound familiar? Knocking the cobwebs off? So in order to express these things correctly, we need to understand the different types of notation. So we're going to look at 3 types of notation. We're going to do that over here in this blank column. So say we've got notation. All right, we're going to draw a little picture that goes with it. It's okay. It won't be a difficult picture to do because I'm not going to make it crazy. So what is this thing? Parabola. Very good. If I had the equation for it, what kind of equation would we call it? Quadratic. Very good. Okay. So the first set of the type of notation that we're going to talk about is inequality notation. Okay. So inequality notation, and we're going to do domain and range. You always go from least to greatest. Domain goes from left to right. Range goes from bottom to top. Right? So my domain here, from the left, I'd be way out here at negative infinity, go all the way to infinity. So for inequality notation, I could just say it's all real numbers. Make sense? So our range, we don't start at negative infinity. From bottom to top, the very first thing I have is 0, and then it's going to go all the way to infinity. So my y values have to be greater than 0. Do I get to include 0 here? Is 0 a value on my graph? Yes. So then I would say my y's are greater than or equal to 0. I'd have to include it with the equals. It's a capital R with 2 lines. It means all real numbers. Okay. So then the next type of notation we have is set notation. Now, set notation can get real fancy and a little weird sometimes, but we're going to kind of do a simplified version of that. So for domain, it's really still all real numbers. For range, it's like it looks like a fancier version of inequality. So it starts with the squiggly brackets, and yes, you have to have them. That's what makes it a set, makes it wrong if it's not there. Then we could put a y here with a vertical line. So basically the way you read that is it's the set of all y's such that, and then y is greater than or equal to 0. So if you had a choice of what form to write it in, I mean, inequality is a lot easier than set on this, but sometimes set's easier because of what you have to write. It just kind of depends. Sometimes you'll have a choice. Sometimes you'll be told what to do. Today you're going to be told some because we'll make sure we talk through all of them. And then the last one, and the one that we're going to use the most, is interval. Okay. And to me, interval is kind of the easiest because it's the way you should be thinking on the graph anyway. You're going from left to right for domain. So you're starting all the way out here at negative infinity, so I can write down negative infinity. And then I go all the way to infinity, so I write down my infinity. Then I just have to decide if I'm going to have parentheses or brackets. Okay, if it's like the less than or equal to. If I'm going to include it, like the equal to, it's a bracket. If I'm not going to include it, it's open, it's a parenthesis. Your infinities, you never include them because they're not actually numbers. Okay, so your infinities will always have parentheses around them. You shouldn't have to think on that one. Okay, my range, going from bottom to top, since y has to be greater than or equal to 0, the first y value I come to is a 0. Then I'm going to go all the way to infinity. I never include my infinities, so that's a parenthesis. Yes, sir. No. And then, do I include the 0? Yes. And so then that's a bracket. Okay. We good? Not good? You're good because you're not done, but do you understand? Do you have a question or anything? Okay, yeah. I'll give you a second, don't worry. You ran out of 0? Okay, there's a way to extend that, but I'm not sure what it is. The little square with the corners. And then do what? Oh. There's a way to do it. Does anybody know how to extend? Okay. So find another blank part. There's a way to do it, but I don't know what it is. What does that do? Oh, it just makes it even worse, doesn't it? You can put it back down there. Why does your phone doesn't like me? What does the hand do? Oh, I think you can write up here. I think you can write up here. You can write outside the boxes that I have. I tried to make them big, like to fill up to give you plenty of room, but try writing up there. And that's okay. It'll get better. There we go. Is that better? Okay. All right. Okay. Are we good? Any questions about the different notations? Like I said, we're going to use interval the most. Set comes up because it kind of needs to. Inequality, sometimes you're allowed to do that. It kind of depends on what we're doing. But what we're starting with and a lot of what we're doing is going to be interval notation. All right, so we're going to do some examples. We're not doing all of them. And anytime I skip examples, sometimes I have taken off all the extra stuff I don't want to do. Sometimes it's not worth my time, so I'll leave it on there and we skip it. You don't ever have to go back and do it. I always forget to say that, and then people think they have to go back and finish. You can if you want to, but that's not what I expect of you. The reason we're skipping is because you don't need 1,000 examples, okay? So it's fine if some of them are blank as long as that's what we did in class, okay? All right, so let's look at number 1. Number 1 says to give the domain and range of each relation, and it doesn't say in what form, but on number 1, you really only have one option. Anytime you have like discrete data like that, where they're basically just points, set is really your only option. So when I'm going to do domain, to start my set, I do the squiggly brackets. Do your best with squiggly brackets. I honestly could not draw one correctly and look halfway decent until I became a teacher. And I took a lot of math classes in college, and mine always looked like a hot mess. So just do your best and you're fine. My domain is all of my x values, and I need to put them in order from least to greatest. So the smallest one I have is -5, then -1, then 3, then 7. Okay. And I promise I'll figure out how to extend it before tomorrow. I have to go ask somebody else. Somebody told me you could do that, and I don't remember what it was. All right, so then my range is all of my y values. So I got a -1, a 4, a 0, and a -1. So -1 shows up twice. Do I write it twice? No, I do not. So I've got -1, and then 0, and then 4. So even though I had 4 complete ordered pairs, my domain and range have a different number of values in them. And that's fine, because one gets repeated. What questions do we have? Anything? All right, so now we're going to jump to number 5. And on these, it says to do it in inequality notation. So that's the way we need to do it. So our domain, we go from left to right. So the very first x value I come to is -3. And then I keep going to infinity. That means all of my x's have to be greater than -3. Do I get to include -3? Yes. So x is greater than or equal to -3. Right? Then my range, the first y value I come to is -4. So -4 to infinity means that my y has to be greater than or equal to -4 because -4 is a y value on my graph. Everybody good with all that? Questions? All right. Number 6. What can I draw? This thing that I can draw in right here that exists on the graph but wasn't drawn, what's that thing called? Asymptote. Very good. So it's an asymptote. Those should look familiar to you. So my domain, and I've got 2 pieces to my graph here. So my domain, I start out here at -infinity, and I go all the way to 3, but I'm not actually going to get to 3 because I have that asymptote, right? That means that for my first section here, all of my x values have to be less than 3. So I'm going to put x is less than 3. Not equal to, because I'm not going to make it there. Then I'm going to say, or there's another part. I start here at 3 and go on to infinity. So here, x is greater than 3, and I say x is greater than 3. Oh, no, it's literally the word or for inequality. That's a good question. Yeah, it's kind of, but it's literally the word or. Okay, so you write in the, I'm going to do the range, do it without looking at mine, and I'm not going to say it out loud. Write in what you think the range is in that form, and then we'll check it out, okay? So I got y is less than 0 or y is greater than 0. Do y'all agree with that? All right, any questions about any of it? It all sounds familiar and we can do this 100% correct? Yes? Okay, speak up if not, even if you feel like, well, everybody else gets it, I'm going to look stupid. No, you're not. It's okay, you're going to get better at it. Okay. All right, so once you're done with that, go ahead and go on to the next section. I'll give you a second to get there. And once there's not an answer blank, it'll be easier as well. I messed up on the first 3, and I didn't realize how bad it would be for you, or I would have fixed it. Because there's different ways I can put this in. All right, so now we're going to look at interval notation. We're going to start with number 7. So I like interval notation better, mainly because, like I said, it's kind of how you think through the graph. But remember, you always have to go left to right, bottom to top. And this does have arrows on it, even though you can't really tell they're arrows. So for my domain would start way out here at -infinity. Then I'm going to go all the way, it's continuous, all the way to infinity. Do I include my infinities? No, never. So it's open. We good? All right, so then my range, going from the bottom, the first y value I come to is -5. Then I go, it's continuous all the way to +5. Do I include -5? Yes, because it's a point on the graph. Do I include +5? Yes. Everybody good with that? Yes. All right, number 8, I have a line that's got a hole in it. So I have two sections of graph. So my first section, I start out here in my domain. I'm going to start at negative infinity. Then as I move along, I go all the way to negative 1, but there's a hole there. So I know I never include my infinities. Do I include negative 1? No, because negative 1 is not an x value that's actually on my graph. Now here's what you were asking about. Here I'm not going to put an or an and. I put a symbol. Anybody know what the symbol looks like? Looks like a U. It looks like a skinny capital U. And it does mean union, but it's technically not a U. It's a symbol that looks like that. And then I start back over at negative 1 and go all the way to infinity, and both of those are open as well. Union and so the union connects two sets of graph, or two sets of data. The intersection would be, it's like almost like a Venn diagram. It's what they have in common, where they overlap. Does that make sense? That's a good question. All right, so my range. I would start down here at negative infinity, keep going all the way to negative 3. Then I'm going to union that with starting over at negative 3, going to infinity. All right, so on number 9, I'm going to show you what not to do, because here's what I see this a lot, and it's helpful when I can figure out why there's a confusion. I'm not really sure why this happens, but please just remind yourself, always least to greatest, because I'm going to write a what not to do up here. And it's good to put on here what not to do too, and then we're going to exit out. But I think maybe it's because it's the way you think, like if you're thinking inequalities, if I'm looking at domain, go, okay, well, I'm going from 0 and then all the way to negative infinity, so I would see things like this, 0 to negative infinity. And that's big time wrong. That's like a bad no-no, because it's not least to greatest. Like, that doesn't make any sense, okay? Instead, I have to think domain. I'm starting out here at the left. I get to start at negative infinity. And then my x values go all the way to 0, and then I don't have any more. Never include your infinities. 0 is an x value on the graph, so it's closed. Okay, does that make sense? So it's like a little process you can think through so you don't mess up something easy. Because I know you can explain it to me, but we also have to write it correctly as well. All right, then my range going from, well, down here at negative infinity to infinity. Any questions? All right. I was going to give y'all a chance to do number 12, but I think we're going to have to do it together because I took so much time at the beginning, but that's okay. So as we look at number 12, we're going to do our domain. We're going to start out here. So the first x I get to, 1, 2, 3, is negative 4. That's not actually a point, but like that's where I'm going to start there. So I'm at negative 4, and then it goes all the way to a positive 1. Now, if I think about traveling this way along my graph, I'm going to get really, really, really close to negative 4, but I never actually make it, right? So I don't include the negative 4. It's open. But I don't put 3.9 because I can get closer than that, right? I put that in as open. Do I include the 1? Yes, I do. Then my range, I start down here at negative 7, and I'm going to go all the way to 2. Correct me if I counted wrong. Do I include the negative 7? Yes. Do I include the 2? Yes. Beautiful. Okay. Any questions at this point? Alrighty. Then you can move on to the next section whenever you're done with that. Let's talk about functions. So what we've just talked about is a bunch of relations. Some of those were functions. All functions are relations, but all relations are not functions. Okay? So a function is a special type of relation in which each element of the domain, so your x's, is paired with, here are two really important words, exactly one element of the range, which is your y value. So every x can only have one y. And you need to be able to identify functions from tables, from mappings, from graphs, from charts, from all kinds of things. So let's look at this. Number 13. It says determine whether the relation is a function. Well, each x only has one y attached to it, so does that make it a function? Yes, it does. What do you think about number 14? No, because this x has two different y's attached to it, and that's a bad thing, so that's a no. What do you think about 15? Yes, even though 8's in there twice, that's okay? It's not the x, it's the y. Y can repeat, x cannot. Yes, you got it. I knew what you were trying to get out of your brain. All right, so you don't have to go back. Stay where you are. You don't have to go back to the other slide. I'm going to go back just to show you something, then I'll flip back. There's no reason for you to go. So let's look at this first chart. Is this a function? No, because this 2 has this y and this y, so it repeats. So and then some of the next one was and so forth, but we'll look at some of these. Okay, so let's talk about the vertical line test. If a vertical line intercepts a relation at more than one point, then it is not a function. Your teacher might have called it a pencil test. I think most people now call it a vertical line test. Everybody's heard of that, right? Makes sense. So that means I can drop a vertical line down anywhere on my graph and only hit the graph once. If that's the case, that makes it a function. So the answer is yes. On number 17, I can drop a vertical line down right there. It only hits it at one point. Does that make it a function? No, because I can also drop a line here, hits it at 2 points. That's bad. The answer is no. What do you think about 18? Is it a function? Yes, because I could put an asymptote here. The asymptote doesn't count. And it might look like these start to go vertical, but they're not actually vertical. So yes, it's a function. Okay? All right, what questions do you have? Okay.